this so I could share it with the world for the benefit of all beings. We're at Silicon Valley Code Camp 2017. I can't believe how many years have passed since I've graduated from college. And it's awesome to be here at PayPal, a monumental historic business location, the history of Silicon Valley and the web, and Elon Musk being one of the founders. Like, incredible to be here at PayPal. And I thought Reid Hoffman had something to do with PayPal, but when I was reading his bio, I was like, no, he was LinkedIn. But I just want to point out this podcast I've really been enjoying recently, Masters of Scale. If you haven't checked it out and you're into coding, you're into startups, you're into Silicon Valley, Masters of Scale is anonymous. As an educator, I'm a professor, faculty tenured at Fresno City College, and I'm also adjunct computer science, California State University, Fresno. Oddly enough, I studied economics as an undergraduate and got a master's in business. Now I'm teaching upper division comp sci students and graduate students in computer science. The Go programming language, but that's a little bit of my background. And I first got interested in Go, and I knew I wanted to learn Go because of Go's credentials. Go, so you're going to just learn a little bit about why Go right here at the beginning. Go has amazing credentials. So it was created by some luminaries in computer science, Ken Thompson, Rob Pike, and Robert Gressimer. And Ken Thompson helped create the B programming language, the C. Yeah, well, oh. Dang, I forgot to do the buttons. Well, we'll just push and hold, and then we're good, right?
Should be. Try
cool.
All right, cool. Thanks.
All right, yeah. So, hey, that was only 2 minutes. Sorry for the silence. I thought we were doing pretty well. That's a bummer, but that's live. Restart it. No, I'm not going to bore you. To hell with the people online. All right, so Go was created. The first thing that got me interested in Go was its credentials, amazing credentials. And so Google, right? Google looked at all the programming languages that existed around 2006, said none of them are meeting our needs, and we need to create a new programming language. And they wanted a programming language that had efficient compilation, efficient execution, and ease of programming. I just like to slow down. I say that one, just say, take a big breath. Oh, man. Ease of programming. Like, beautiful. You know, I don't know if you've seen that picture of JavaScript, like the complete JavaScript reference and then the good parts, like 2 different books stacked side by side. You could Google it, but ease of programming. Oh, right? So Google wanted a language that could do all 3 of these things. These were their express intent. At the time, they said you could have any 2 of these 3. And to create this new programming language, they hired some luminaries in computer science, some of the heaviest hitters in computer science, Ken Thompson, Rob Pike, and Robert Gressimer. Ken helped create the B, the C programming language, Unix, and UTF-8. Have you heard of those? Right? And Rob Pike, Unix, and UTF-8. Rob Gressimer, a couple of other things. Right? But like, these guys got together in 2006, 2007, said, let's create a new programming language. What was going on in 2006 in hardware? We had just come to commercial dual-core processors. 2006, 2005, depending upon who you talk to, the first commercial dual-core processor was released, which meant that all other programming languages created up to that point in time were built for machines with a single core. A single core. None of the languages were built to natively, ease of programming. Easily take advantage of multiple cores to do concurrency and parallelism. How many people know the difference between concurrency and parallelism? Cool. So concurrency is it's a design pattern. You write concurrent code which might not run in parallel if you stick it on a machine with 1 core. It's not going to run in parallel. You wrote concurrent design pattern in your code, you stuck it on a machine with 1 core, and it could only run 1 thread at a time. That's not going to run in parallel, right? If you have concurrent design patterns and you put it on a machine with multiple cores or multiple machines with multiple cores, right? Now you have multiple cores to take advantage of, and your code can run in parallel. Concurrency, design pattern. Parallel, execution, right? Get it? How many people know the difference between concurrency and parallelism? Put your hands up. Awesome, right? How many people know Masters of Scale is a podcast that you have to be checking out? Right? Okay, awesome. And like, hopefully I'm mentioning this so I could tag Reid Hoffman in my Twitter post. Say, hey, Reid, totally mention Masters of Scale in your talk. And then he'll like retweet to his billions of people. So this was all created with Go on the back end. This is like, you know, this is a website that, a project I've been involved in. I got ahead of myself there. So efficient compilation, efficient execution, and ease of programming was why it's created. If you go to the official website, golang.org, and I'm going to go fast because we only got 45 minutes. Golang.org, documents. Click on documents. Come down here, there is an FAQ, frequently asked questions. Come into the FAQ, why are you creating a new language? And you come down here like, why? Like, there's enough languages, man. I got enough on my plate. There's too many things to learn already. Oh, ease of programming. And created by luminaries in computer science. Like when Google says we need a new language, like I stop and I turn my head and I listen. Do you? Wow, cool. All right, so that's the FAQ, ease of programming. And then programming should be fast, productive, and most importantly, fun. So Go puts fun back in programming. And if you look at some diagrams, right, fast and efficient for computers down on the bottom, and this is from Brad Fitzpatrick, fast and fun for humans on the left, and you can see the layout of the different languages. Go is both efficient for computers and fast and fun for humans, right? Whereas C is efficient for computers, not so fast and fun for humans, right? Ruby, Python, fast and fun for humans, not so efficient for computers, right? So a little bit of a layout there. And then, so what we're talking about here is the efficient execution and the ease of programming in that diagram. And in this one, beautiful, straightforward code, like Go's got that, Erlang's got that, Ruby, Python, Perl, JS, efficient concurrency, right? You could see those down the bottom. C, C++, Java, awesome efficient concurrency. Beautiful straight code, not so much. Right? So that's what they were really going for, is efficient compilation, efficient execution, and ease of programming. So takeaways from today's talk: concurrency versus parallelism, Masters of Scale podcast, why Go is created, efficient compilation, efficient execution, ease of programming. Fun is fun to build stuff in Go. Here's an example of what you could do, efficient execution. Initially, this is from a web company in China. I'll let you read. I'll read it to you. Because as soon as you put text up on the screen, everybody's like no longer listening to the talker. They're like reading it themselves. Initially, our Go-based system ran on 20 servers, 20 machines, right? With 20 million real-time connections in total. Wow. The system sent 2 million messages a day. Wow. On just 20 machines? That system now runs on 400 servers supporting 200 million real-time connections. It sends over 10 billion messages daily. Whoa. Wow. So what you could do is you could write code that could scale much more easily, efficient execution, efficient compilation, ease of programming, scale much more easily, and I'll take questions at the end. We'll save some time for that.
What system is that?
That's Go. That's written in Go. That's the primary back end. And it's here at the Go blog, the official website, Kihu360, the official blog of the Go programming language at golang.org. It's called Golang, the Go programming language, but when you Google it, you know, you Google Golang, you know, concurrency, because if you do Go concurrency, you'll get different results. So Golang is often what you, but it's Kihu is the company in China, and Go is initially huge in China. It was released version 1 March 2012, became huge in China because China has to deal with, if you think that you are 1 in a million, there are 1,300 people just like you in China, right? China has to deal with 1.3 billion people. And so when Go came out, efficient execution, they're like, I got to figure this out. We're trying to deal with like way too many customers. And so is huge in China. When I first started learning Go, I literally was reading a book that was originally written in Chinese and translated to English. Try learning a programming language in Chinglish. It's really hard. But I was like fiercely committed. I got in, you know, early. So it's performant. It's got multiple, it takes advantage natively of multiple cores. Bill Kennedy, who's huge in the training industry, the Go ecosystem, talks about mechanical sympathy. The language is designed to be sympathetic with the hardware. So whatever hardware it's executing on, it adjusts itself to execute in the most efficient way on that hardware. So natively takes advantage of multiple cores, natively has concurrency baked in a super easy way. It's compiled, it runs well in networked environments, has a clean syntax, has a powerful, huge standard library. It's garbage collected, it's portable. I could code on my Mac and then compile and have it run on a Linux and upload it to my server at AWS, which is running Linux. Right? So you can cross-compile to different architectures from your system. It's backed by Google. It's open source. What other language is used for all these? Web apps, network servers, mobile applications, machine learning, image processing, load balancer, system admin, hardware scripts, and crypto. Right? So it's more systems level. It's lower level, but it also, can do some things with the standard library like, hey, I just need to create some websites and serve some pages and create some routes or create a web API. Right? Like, it could do all that super easily. And tomorrow I have a presentation, I think at 11:15, where I'm going to talk about Golang Web Dev. And so we'll explore how do we use the NetHTTP package, how do we build a simple web service with simple routes. You'll see all of that. It'll be like 30 minutes, and you'll be able to walk out and with the code samples given to you tomorrow, like use that to build a website for, 5 pages, 5,000 pages, whatever you want. All right, so a few other people's perspectives on what Go is used for. If you're watching this online, you can pause the video and take a look at that. If you're watching this online, see you boys, you can pause the video and take a look at that. This is from Bill Kennedy. This is from Caleb Doxey. When I was learning Go, I hired Caleb. I brought him in. I paid him a boatload of money every day for 20 days, right, for 8 hours a day to teach myself and all the faculty in our region how to use the Go programming language. This is from his book. He's got a great book on the Go programming language, Caleb Doxey's. Who are the companies using Go? You ready? Get your focus mind on. You ready? Here we go. We'll stop for a second, a little bit longer there. You see some images you recognize? And then these are a little bit more esoteric. And this one. So we created Greater Commons. One of the things we wanted to do with Greater Commons is have it be an example of what you can do with Go on the web. And we're building this in with a microservice approach using Goa on the back end, kind of a framework to help us do it. And we're going to be teaching the different microservices. You could come to this website. I have an entire training on the Go. This is the pitch where I get to sell you something. On the entire Go programming language, learn to code the Go programming language right here. This one. And then also Golang Web Dev right here. And those will teach you everything you need to know about Go. It's the curriculum we've been using at the college and the university. And then the last reason you might want to learn the Go programming language. Have you heard the Go programming language is the top paying language in America? And that's super blurry. But if you go to, let me just bring it up. I'll go to that tweet. So, top paying technologies by region, Go and Scala are $110,000 a piece. So it's gained a lot of traction in industry, and it's become really popular, and it's a really fun, efficient execution, efficient compilation, ease of programming. Right? It's a fun language to work in, and a lot of companies want to use it, so there's a high demand for developers in Go, and there's a low supply of developers. And so one of my jobs as an educator at the college and university is to prepare students to get out there and get jobs and make money. And so I'm super happy to be able to teach them Go because I know I'm doing them right. I'm not teaching them something that I learned when I was in school just because I know it. I don't want to learn something else. I'm like, look, here's what's coming. Get in front of it and let it hit you, right? And then send me a check. So a little review. Golang is awesome. Holy crap. A lot of great companies are already using Go. You should have already learned Go a year ago, but at least you're learning it now. So let's look a little bit at coding. And if you want to do some, first I'll give you, I left off the resources. I wanted to give you resources, and this is where you get to take a picture with your cell phone. So I'm going to bring that up. And resources, right here. So you could go to that link, and this is the link to the course outline and the entire code base for Learn How to Code Go. So take a picture of that link right there. That's going to hook you up. and give you everything you need to learn the Go programming language. I'll zoom in on it and make it a little bit bigger. That's a 2AS7IE. 2AS7IE, and it's going to take you to a Google Drive folder. When you get there, you'll be in this folder, and inside this folder you have a course outline. Here's the course outline, right? So all of this stuff, you'll be able to scroll through this 12 pages, 14 pages, 22, 33, 39, 47, 50, 60, 70, 77-page course outline of learning the Go programming language, table of contents. These are people in there right now who are currently in the class learning it. That'll just keep popping up there. And there's also course resources here, where when you come in, you know, you'll have like you know, links to the books that I've read and liked on the Go programming language. So getting you up to speed. And then also, if you have any questions, there's my email. You can take a picture of that, and you could email me, and either myself or I'll give it to one of my students as an assignment. Help this person figure out their problem. I'll give you extra credit. And so you can email me if you have questions. That's Todd@greatercommons.com. Sometimes I'm not the world's fastest responder to email. It takes me 2 or 3 days just because I'm completely overloaded. And like literally I'll be like, oh crap, I haven't looked at my email in 3 days. So that happens. All right, so now let's do a little coding. And we got 18 minutes to do that. And I will point out that the Golang website, when you're at the website for Golang, you go to Documents, and then in here, right, just skip this, a tour of Go, because you'll be completely confused by like the 7th exercise. And how to write, unless you're like black belt, amazing. How to write Go code is an okay thing. But this, effective Go and package documentation command, language specification. Effective Go and language specification, that is the horse's mouth. Okay, that is the oracle written by the Zen black belt samurai masters. They wrote it in an interesting haiku language in that it's super dense. It's only like, the language specification is only like 60 pages long, but like I'll reflect on one paragraph for like a month and I'll be like, oh, that's what it means. Finally, right? And so, you know, it's something you go to find an answer. My course, I show you how to read it, walk you through it, and give you an introduction to it, but don't be surprised. I know somebody who's been programming in C professionally every day for 20 years, said it took him 6 months before he understood the language specification completely. I was like, wow. And he's like an amazing person, so don't be turned off if you go to that and you're like, what? I don't know anything. All right, let's do some coding. You could go to the playground, the Golang playground. Now, one of the problems with academia is the last time I coded in Go was May. I haven't coded in Go since May. My class this semester got canceled. Please write a letter to my dean and tell him that was a bad decision. But I haven't coded since May, so let's see what we can do and see if I was just, you know, we'll see what help me catch my mistakes is what I'm trying to say. All right, so I'm declaring a variable. That's the short declaration operator. Ease of programming. Go is statically typed. I don't need to specify the type, but it's all in there, and I can't do willy-nilly, loosely assign, hey, this variable stored in int, now we're going to store a string in it, whatever. Can't do that in Go, right? No, it's static, right? Static, it's static, doesn't change. So if this variable is declared it's declared, initialized, and assigned variable of type string. The type is figured out. If I look at the type and go in here and say, show me the type on that, right? It says, hey, I'm storing a string in there. So that's how we declare a variable. I could also write a func foo, and I could say, I want you to return a string, right? And so anytime you declare a function, it's the func, and then the receiver, and then the identifier, and then the params, and then the returns, and then your code. Okay, anytime you do a func, and so I've got func foo returns a string, so I'm going to return. How many people like seeing live coding? Raise your hand. I'm serious, because I'll stop if you aren't liking it. It makes me a little nervous. Right? Foo runs, returns a string, Todd, and I'm going to print that out. Okay, awesome. You could also, Go is all about type. It's all about type. Like the masters of computer science got together and said, what's the next iteration on programming languages, developing languages? We've had object-oriented, right? We've had structural, procedural, back to spaghetti code. What's the next step? They took it into a direction which evolves object-oriented to the next level, what they see as the next level. It's all about type. When I started learning Go, people say it's all about type. I was like, what's that mean? Right? It means it's statically typed. You could create types. You could attach methods to types. Whoa, interesting. Let's see some of that. I'm going to create a type person. It's going to be a struct. A struct is a composite or aggregate variable type, right? Which means that I'm going to bring together variables of different types. Composite, aggregate together, compose together variables of different types. It's a struct, aggregate composite variable type, but it's a type. It's type person, like type string, type int, type bool. You know, person is now a type. I created a new type in my language. So first, last. Now I'm going to create a person. I'm going to do that with a composite literal. And a composite literal is, okay, there's my variable. There's my short declaration operator. A composite literal says, you got to say what type it is, and then curly braces, and then stick the values in there. I'll show you one more example of a composite literal. Slice of int, right? So if I have a slice of int, which is like an array in other ones, right? That's a composite literal. My type is a slice of int, curly braces, and then values inside. My type is a person, curly braces, and now values inside. I'm going to do first, and first is going to be James, because this is who I think my alter ego is, and I left off the type up here. And last is going to be, you guys didn't catch that, come on. Last is going to be Bond, right? And now I'm going to print out, instead of all this, I'm going to print out my person, and also I'm going to format print line and print out my my slice of int, and that's a print line. So I'm going to have my person and my slice of int. I'll bring this down here. Boom, 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 right? And so that's going to print those out, right? So composite literal, another takeaway for you. You got the type, and then you have the curly braces, and you have the values. So format that, run it. James Bond, there are my values. Beautiful, right? Let's explore this a little bit more. And this is just an introduction. You get the whole walkthrough nice and slow, and usually with me drinking a beer, teaching you how to do this in that course. I'm going to do secret agent, right? And secret agent is, they're going to be everything a person is. Whoa, I'm embedding a type in another type. I don't want to say inheritance, but there's intertype promotion. That's the word I wanted to use. There's a new vocabulary, new language we use to talk about the language. The authors of this language are really precise, right? Yeah, in case matters. Yeah, you like the loosey-goosey. All right, I can tell by the expression on your face. And this next one's going to be bool, right? So I'm going to change this here. I'm going to copy that. Person will be miss. What am I going to type next? Moneypenny. And secret agent, same thing, composite literal. I want a secret agent. So I put my type in, and then curly braces. Now I'm going to do my values, and here's my values. The first value is going to be person, and then the next value is going to be license to kill, and that's going to be true, because James Bond's got a license to kill. And then I'm going to format that. That all formats. I'm going to print out my person, which will be Miss Moneypenny, and I'm going to print out my secret agent, and that will be James Bond. Ba-bam, ba-bam. Beautiful, right? Yeah, like let your mind. We are innovators. That's our industry. We are destroyers of industry. We're like superheroes. Like we come in with our knowledge of code, just like this blazing sword on fire, and we destroy industries and create whole new ones. We're innovators. But then get everybody in a room and say, look, I want you to switch from OOP in Java to like this new way of type. What? Wait, I thought you guys were innovators. Right? Isn't that funny? Jim is laughing. My colleague. You teach long enough and it becomes a funny job. All right, so now I can create some methods, and I'm going to do a method, and I do that with a receiver. So person is going to speak, and no params, and then my code. And so we're going to have just a print line, and we'll say, hello from p dot first, right? And then we could also do that, I feel like maybe I blew an error in there. We could also do that with secret agent, and secret agent's going to speak, and hello from secret agent first, and then come down here, and we could do p.speak, secret agent dot speak, and we'll call those two different methods. Undefined println. See, I knew there was something in there, even though I didn't read it. It's like it wasn't right to my eye. Hello from Miss and hello from James. So I'm going to do p dot last just so that reads a little better because I got some OCD. All right, sweet. So I've got those, and then we could do polymorphism, meaning morph, change, poly, many, right? And we could do a new type. We could do a new type, and that type is going to be human. And it's an interface, and interfaces are implicitly implemented. You don't have to explicitly say, hey, this implements that interface. Anybody who has the speak method, any type, any value of a type that has the method speak, implicitly is going to implement the human interface. So I could create a func human, right? And I could create a func foo, which takes in a human. And I could put my code here, and I could say h.speak and call that. And then I could say, okay, I want foo to take in a p, and I want foo to take in an SA, values of two different types. But the variable p is storing a value of type person. But since type person has the method speak, and the human interface says if you have this method, you are also of this type, then p is storing a value. P is storing a value which is of type person and of type human. So I could create a function that takes in a value of type human, and I could pass in a person in the same situation for a secret agent, or I could pass in a secret agent, right? And that's polymorphism, one function taking in values of two different types, right? And if I format that and run it, boom, right? It does it again right there. That's a receiver. That's how you make it a method. That's new to Go, right? So you're like, so this is a parameter. I'm declaring this function has these parameters. I pass those arguments into it, right? But up here, when I have this in front, that means, okay, there's a type person, and it now, any value of type person now has the method speak attached to it. So I could just do p speak. P-speak. And so inside the function, it behaves pretty much just like a parameter in that you've got a variable, right? And you could call things off of that variable. But that's the syntax for making it a method. That's a great question. Good insight. That's really quick of you. It is, right? Because I just threw a lot of stuff at you fast. Do you code every day for a job? Yeah, so that's what, you lucky dog. I go like 7 months, and then they're like, can you teach this class again? I'm like, oh, I got to get back in the groove with it. I'm almost ready just to start working full-time programming. So that's like a little introduction to the Go programming language. I finished that ahead of schedule, which gives us extra time for questions, and we could do a little coding. So, yeah. Yeah, so you could just Google for web frameworks, Golang web framework, and different options come up, and you could evaluate between them. It is still a relatively new, young language. It came out March 2012, but there's some good stuff out there. But in my web dev course, Go for me is really a language which allows you, if you are a master, to build it all yourself. And so in my web dev course, you could use the built-in servers that come with the net HTTP package, or you could go grab another server like Julian Schmidt has a router, server, mux, serve mux, right? You'll learn what all that is in the web dev course. Or you could build your own, and I show you at the TCP level how to build up your own server. And then also you could do all of your session and state management yourself. So you don't have to rely on a framework and learn somebody else's implementation. But my web dev course will show you how to do all that yourself and create your own sessions. You've got your own code, its own package. That way you know everything that's going on behind the scenes. There's arguments for and against using frameworks, right? Like, use a framework, you learn somebody else's way of doing it, and you're like, well, I'm abstracted away from the language a level, and I know this thing really well, but I don't know how the language does it. So, and Goa is the choice that we made for the Go programming language right here, right? For our website, Greater Commons, we're using something called Goa. And Goa is a little bit niche, and but I think it's got a ton of potential, so I hope its popularity continues to grow.
Why do you think that they haven't?
So humans are not rational creatures. There used to be this thought that, you know, rational economics, but there's like all these crowd dynamics and crazy stuff that happens, and the world just kind of evolves. And so we don't always choose the best technology. Beta was better than VHS, right? Apple was better than Windows. Unix, right, is better than dumb operating system, quick and dirty operating system. You all don't know that story. But, you know, we don't always make the best choices. And Python, you know, Guido, I don't know who Guido is. Did he help create the C programming language? I don't think so. Did he help create Unix? I didn't see his name in the list. B, the B programming language. You know, UTF-8, he wasn't at the table for UTF-8, right? So Guido, hats off. He created one of the world's most popular languages. But is it as good as Go? I don't know, man. Based upon the credentials, I'd say no. That's literally how I think about things, right? And if you do teach, we're looking for teachers. So this website here, Greater Commons, it's a place where you could create a course and share your knowledge and passion with the world. I used to work for a Wall Street firm. I was on track to make $500,000 a year, and they're doing some stuff, and I was like, wow, we could go to jail for a long time for this. And so I quit, and they later got busted for it, and they didn't go to jail. They paid a huge fine and still all have huge houses in the Hamptons. But I then thought I'd take a year. My dad was a college professor. I'll take a year, I'll teach at the community college. They hired me to teach accounting, and then I just never left because I liked teaching so much, and I liked helping people. I just found it really intrinsically rewarding. And so this is an opportunity for all. You have a knowledge specific, right? Whatever your day job is. Like literally after work, I'll sit down and I'm in my t-shirt with a baseball cap and a beer, and I'll just be like, all right, now let's learn about this. And I just teach whatever I know, and then I put it up there. And last year I taught 528,918 students online. And the great thing about it is seeing all the people in Nigeria, you know, Libya, all over the world, India. I've got friends, you know, people who've taken my courses, and to help people, but then also to generate some extra income. And so it's low key, just record it, get it out there, make a course, teach what you know, and you upload it here. And we'd love to have you be a teacher. I've got business cards on the chairs on the back, so grab them on your way out.
Did you ever, or do you